Hi and welcome to part 4 of the Pointsense Revit tutorial series. In this video we're going to take a look at calculating the surface deviation of modelled elements from point clouds, hiding and restoring results and transferring them between views, switching between deviation analysis result modes, and exporting the results for analysis and use within the other Pointsense tools. Okay, so we open up Revit now, and the tools we're going to be looking at are the surface analysis tools here in the Pointsense tab. We're going to click Calculate first, which opens up the Select Faces tab. We have a category of face hosted objects available, which we can turn on and off to aid with the selection. We also have face orientations, which we can turn on and off to allow us to make an accurate selection. We can enable the temporary hide point cloud for selections tab, and also we can enable the selection of in-place families if we do have any. These are all just to help with your selection and to show you what's available to select. So we press OK and we go into the 3D view here. Obviously the 3D point cloud's been turned off because we did have that box ticked. So we're just going to go now and select the front face and the rear face of this small wall which we created in one of the previous tutorials. Once we've done that, we just need to go up and click the Finish button here, which has appeared in the top left, and we're going to get the Surface Analysis tab which opens. We can now set some parameters before we click Calculate, so we can change the grid size that we're going to calculate the analysis at. So it's defined at 50mm as a default. We can change that to 100mm, or we could just leave that at 50, which is as good as any setting. We can change the surface distance that we want to calculate the point cloud from the model. So I would normally put this around about 100mm, and we can change whether or not we want to use just the positive side, which we'll look at later. Once that's done, we just click Calculate. So if we navigate around now, you can see we have a graph which has appeared showing the scale of our results along with a heat map on the surface of the model. On both sides of the surface of the model as we calculate two different surfaces, and the colorization links back to the graph there and gives us a deviation of the point cloud from the model itself. Obviously that's up to 100mm, which we set previously. If I just drag that along there, if I wanted to go into this and have a bit of a look at it, we can change the style of this display. In the settings tab here, we can edit the display to show grid lines and contours. If we wanted to do that, we can edit the colours of the actual graph itself, or the gradients of the result displayed. And in the legends tab, we can also edit things like the text sizing, customise the colour range and things like that. If we wanted to create a new default or a specific analysis display, we can click on the Properties tab there and into the new styles and add one in and save it and use it again. So the next thing we might want to do is just hide that off. So if I just use the hide command and select that surface, then click Finish, you'll see that disappears. If I want to bring that back, I actually can use the Transfer tab and click that surface again and click Transfer. That's going to bring the surface back in. And similarly, if I wanted to move that analysis to the same object in a different view, I can open that up in a different view, and I can use the Transfer tool. So let's just create a section on the front of this wall. Just change the scale a bit here so we can see what we're looking at. And if we just want to go to the Pointsense tab, Transfer, click on the surface and click Finish, and just hide that point cloud off. You can see that same deviation map's been brought in on that view to the same actual model element. Let's just go back to the 3D view then, and we'll bring that point cloud back in. Now if we just take a look at this wall here, and calculate a quick surface analysis on this. So we'll just run through the same tools again. We'll take a look at the difference of the results when we use the positive side only tool. So let's run this first as it would be, and we'll see what results we get. So just calculate that. Now you've got to think we've got windows here which are going to be behind the wall, so this is the type of thing that's going to be ignored in the next step when we turn that feature off. So just hide that point cloud off. So this is the results that we're getting. You can see we've got big blue areas where the windows and doors are, because obviously these features are recessed into the wall. So I'm just going to zoom out a little bit here and just try and select this actual analysis result to give you an idea of how it appears in the properties dialog. So on the left you can see some information about this, and we can click on the visibility settings if we want, and we can hide off all the results or an individual deviation result. We could also change the style here if we wanted to. So just click OK there, and we will just delete this particular analysis result completely, and I'm going to go and run that calculate tool again. Just turn the point cloud back on, run that calculate tool again, exactly the same. However, this time what we're going to do is we're going to tick the box that says use only the positive surface side, and you'll notice we get a very slightly different result. So there we are. If I just hide off the point cloud so we can see that, now you'll notice the windows now have been ignored, or the results have kind of been ignored in those areas, anything that was behind the front surface of that model element in this particular task. So if we take a look at the values in more detail now and look at the graph or legend we have, this will scale similar to the way most annotations in Revit will. So if we change this to 1 to 200 and back to 125, you can see it's obviously changing its display. Now we can switch the value that is displaying. You can see at the bottom we've currently got average value, which is data set 0. If we switch between these, the display will update along with the graph, and you can see in the bottom left corner I've just taken a snapshot from the help menu to give you an idea of what these different data sets mean. And if we just select the surface itself, we can actually update those via the properties dialog as well. It's important to know this because we will be using one of these results for the export features next. So let's go and take a look now at the export results tab. I've created a surface deviation plan of this first floor level here to give us an idea of how we could use this tool, and what I'm just going to do is go to export results, and I'm just going to click on this analysis result, and I'm going to click finish, and we get the export results menu appear. So the first thing we can do is export as a text file, which could be imported into Excel if we wanted to. We need to choose the value that we're going to use from the different values we can select, and also select the naming conventions. If we wanted to, we could export as construction points and profile lines, but we'll do that next, and I'm just going to click OK and yes here and export that. So there's a text file with the exported results from the surface deviation plan. I think that one was at 50mm spacings, so that gives you an idea of what you can get out and could import into Excel. So let's go export results again, and this time we're going to use profile lines, and we're going to use the average value. Now you'll notice there's a blue line appeared and a red line appeared across the analysis result here. This is to give us the indication of the directions of the profile lines we can export, or if we want to, we can export both. There's a section here that says create closed profiles, so if we wanted to close the model lines we can do that, or we can have open model line chains. So I just click OK. Now you can see some model lines have appeared along that analysis result at about a 50mm spacing all the way across. So if I just click finish, we can hide that analysis result off, and we can get in and have a bit of a look at that. Okay, so I'm just going to close down the Revit project and restart it. Now you'll notice that removes all of the analysis results. They're not saved in the project, just in the project file. So to bring those back in, I have to use the restore button. Now you'll see if I hide off the point cloud again, those analysis results have reappeared that we created before. I've temporarily hidden off the construction points and the model lines that we created for that floor. And I'm just going to go in now and I'm just going to create a new floor beneath this road, because what we're going to do is we're actually going to create a heat map or a deviation map, and we're going to look at how we can use that to create contours and construction points which we can use with the topographic functions and also the deform shape functions. So if I just drop a square area or floor beneath this road or in the road, we're just going to go into the section here and we're just going to move that down so we know it's guaranteed to be beneath the surface that I'm just going to calculate the analysis results for. So I'll just drop this section area down a little bit. So go back into the 3D view there. Now you can see that is completely beneath the road that we're going to use. So I'm just going to go to calculate, I'm going to deselect all and just select floor. I'm going to go to select and I'm going to select the front face of that floor. I'm going to tweak these parameters slightly. So we're going to have a grid size of probably about 750 and a surface distance is going to need to be big enough to actually capture the road above, so about 1.5 meters. So there we are. And we'll just click calculate. Okay, now you can see that's complete. I'll just hide off the point cloud. So we've got a generally increasing distance between the model and the point cloud. So if I just go in and export these results, and this time we're going to use turn off the text there and we're going to use construction points with an average value. We could do profile lines at the same time now, however I'm just going to use construction points for this specific example. So turn that off and just click OK. So we're going to get about 330 points from this analysis. Just takes a second to regenerate. Now I'm going to have to go in and actually unhide that category of the actual construction points themselves. So I'll just go into reveal hidden elements. I'm just going to go there, you can see them appear. And we just need to unhide that category. There we are. Bring that back in. And you can see, just bring that point cloud back, there we are, just bring the point cloud back in. You can see we now have 330 construction points, and if I just navigate around slightly you can see that these are generally increasing up that slope. So in one of the later tutorials what we're going to do is we're going to use those to create a topo surface. So there you are, if you just go underneath you can see there's a generally increasing gradient up that road. So that's construction points. The next feature I'm going to look at is using the model lines to do a similar function. So we're just going to go and find another area in the point cloud, and if I just zoom out slightly and go to the back of this site where we have a bit of a slope. So what I'm going to do is go back to the site tab, and I'm just going to go and I'm going to navigate across, and I'm going to just drop a generic floor beneath that, which we're going to use as a base for this surface. So again I'm just going to go to architecture and I'm going to go to floor, and I'm just going to draw a square beneath the area we want to calculate. You'll notice there's a little bit of noise, things like bins and benches and things on this, so they'll all be likely to be picked up in these results. Just going to drop a section through to check the type of distance I've got between the point cloud and the floor in this instance. So just drag this view up a little bit. There we are, yeah. You can see there's a little bit of noise there. So if we go to the 3D view and we just run that analysis, I'm going to select the face of this floor and click finish, and I'm going to set a 250 mm grid, and I've got 10 meters as my search distance. I'm just going to click calculate there. And there is our results that have appeared. So you'll notice they're all very dark blue. That's because although there's a large distance between the surface and the point cloud, the actual difference between the point cloud itself, or the difference between the Z between the top and bottom, is very small. So that's why we're getting a large amount of blue. So I'm just going to export that as model lines. And if we just navigate around slightly, you'll see there's all our model lines at the 750mm spacing. And if we hide the point cloud off for a second, see that a little bit better. So there we are. You can see the terrain sort of surface that's been created by those model lines.
So in the next tutorial, we'll look at how we can use these model lines and construction points with a topographic function and also the deform shape function.